In this video I'm going to do Edexcel A-Level Maths, Paper 1 from June 2018, Question 5. My name is Sunil Tanna. I'm a tutor and an author. I'm available for one-to-one tuition, both online and in person. I live in Buckinghamshire, England. Okay, question 5. Given that y is equal to 3 sine theta over 2 sine theta plus 2 cos theta, show that dy d theta is a over 1 plus sine 2 theta, where a is a rational constant to be found. And we're also given that theta has to be in this particular range, although you don't really need to consider that for the question, as you will see. Okay, so looking at y, we can see it's a quotient. Now, we have to calculate the derivative, we have to use the quotient rule. So you may remember when we have a function of f, x d by dx of f over g is equal to f dash g minus fg dash over g squared. Sometimes people use letters u and v, or perhaps they write the top one as g f dash minus fg dash, but it's the same formula. There's just different ways of writing that down. Okay, so the only difference here is instead of a function of x, it's a function of theta, so we differentiate with respect to theta. So in this case, f would be 3 sine theta, and the derivative f dash would be 3 cos theta. Likewise, g would be the bottom, 2 sine theta plus 2 cos theta, and the derivative g dash would be 2 cos theta minus 2 sine theta. So dy d theta, applying that formula, will be f dash g, so 3 cos theta times 2 sine theta plus 2 cos theta minus f g dash, so 3 sine theta times 2 cos theta minus 2 sine theta, all over g squared, so all over 2 sine theta plus 2 cos theta, all squared. Okay, so now we need to simplify that expression. First of all, we can expand out all the various brackets. So dy d theta, expanding out the first bracket on the top, we will have 6 sine theta cos theta plus 6 cos squared theta. Then expanding out the second brackets, be careful because of that minus in the middle. We'll have minus 6 sine theta cos theta, and then minus times a minus makes a plus, so it'll be 6 sine squared theta. Now on the bottom, we could do the FOIL or square this out. So 2 sine theta times 2 sine theta, which would be the f of the FOIL, will be 4 sine squared theta. The o and the I of the FOIL will be 2 cos theta times 2 sine theta, so that would be 4 sine theta cos theta twice, so it will be 8 sine theta cos theta. And then the L of the FOIL will be 2 cos theta squared, which will be 4 cos squared theta. So now what we need to do is use some trig identities. There's 2 relevant trig identities here. First of all, cos squared theta plus sine squared theta is always equal to 1 for all values of theta. And secondly, we can use the double angle formula, which tells us that sine of 2 theta is equal to 2 sine theta cos theta, again for all values of theta. So applying that to this formula, we can see first of all on the top the 6 sine theta cos theta is also minus 6 sine theta cos theta, so those will cancel out. And we've got 6 times cos squared theta plus 6 times sine squared theta, so that's 6 times 1, or just 6 on the top. On the bottom, we've got 4 sine squared theta plus 4 cos squared theta, so in other words, 4 times 1. And we've also got 8 sine theta cos theta, which is the same as 4 sine 2 theta. Now, if we look at the formula that they've asked us to produce, they want 1 plus sine 2 theta on the bottom. So we need to divide top and bottom by 4. So it will now be 6 over 4 on the top, and then 1 plus sine 2 theta on the bottom. 6 over 4 simplifies to being 3 over 2. So it'll be 3 over 2, 1 plus sine 2 theta, and the value of A is 3 over 2. And that completes question 5.